all, let's start with light emitting diode. So Now let's talk about solar cell. So it is a junction diode in which one of the P or N section is made very thin so that the light energy falling on the diode is not greatly absorbed before reaching the junction. So we basically want to have a thin diode. Why? Because in this case we want that light to reach the junction diode to initiate the electron hole recombination. So therefore, we have made the P diode as very thin and N junction as thick enough. So therefore, these are known as solar cells. Why we are making it thin is because we want that light energy to reach this junction. So to initiate the electron hole recombination, if we make P thick, then it won't be able to reach junction. Now it could be opposite, like you can make N thin and P thick. Again, it can initiate electron hole recombination. It can easily work. So you can use vice versa, but you can't make both junctions equally thick, or you can't make it very thick. It won't work until or unless they are very thin. So remember that you have to make one junction or one section as very thin so that energy can reach junction, so that we can have benefit of it and we can make use of it. So you might have heard that the calculators, the small batteries make use of solar cells in it. So they work on solar cells, they absorb sunlight to convert it into electrical energy, then only we can use them these days. So that's about solar cells. Now the next one is Zener Diode. This is the fourth one and the last one. In this case, this is again a diode, and it is a junction diode again, but it is a special type and it is made like this. We have a triangle in it and an integral sign. So in this case, P is the triangle and N is again the integral sign, which we can name it as. And this is actually a specially designed junction diode. Why? Because it can operate in the reverse breakdown voltage region continuously without being damaged. They are doped such as they can work for a specific voltage. You can make use of them at a specific voltage, and that too it will be a constant. That means it will make a constant voltage. Therefore, these diodes find a very good use in the breakdown voltage, or you can say Zener diode as a voltage regulator. We are using Zener diode as a voltage regulator. Why? Because it can give us a continuous same voltage after some point. Now let us study the characteristic for it. So we have a setup here. In this case, you can see that we have a resistance, we have a fluctuating DC input, we get a constant DC output. So in this case, you can see that a Zener diode is actually very similar to the ordinary diode, except that it is properly doped so as to have a sharp breakdown voltage, as you can see in the reverse breakdown. You can see here that they have a sharp breakdown voltage, whereas in the case of ordinary diodes we didn't get a sharp breakdown voltage. In this case, this voltage remains constant throughout the system at a particular point. So remember that Zener diode is always reverse connected, because you can see that we are getting a reverse constant voltage in the reverse graph. So therefore, first thing is that it is reverse bias always, never forward bias. If you do it forward bias, it will work similarly to the ordinary diode. You can see it is the same graph. Now, the second thing is that they have a sharp breakdown voltage, which is known as Zener voltage. And the third thing is that When you do forward bias, its characteristics are just those of ordinary diode, as discussed earlier. Now, the very important property is that Zener diode is not immediately burnt just because it has entered the breakdown region. If it has entered this region, that doesn't mean that it will burn out. It won't burn out anyhow because it is made such that it will work for this particular constant voltage. So we can use it as a voltage regulator so that we have a constant voltage. So this is the use of the Zener diode, and that's all about junction diode. So we discussed Zener diode, we discussed solar cell, we discussed solar cells, and we discussed LED, we discussed photodiode. So these are under junction diodes. So that's all about it. Thank you.